Hi, everyone. We're going to pick up where we left off, Chapter 4, Section 4, and this is starting on page 228. We'll be discussing percentage problems. So with this section, you'll be able to solve any type of problem that involves percentages. And there are three ways to approach it. We'll be covering all three. So I'll start off on page 228. And this definition, part over base is equal to rate over 100. Want you to make sure you memorize this setup, and you'll need to just memorize how it's the ratio of part over base is equal to rate over 100. And then I'll go through the meaning of each of these variables of P, B, and R. And the reason it's set up in this way as a proportion is because you have a ratio where you're comparing a part of an object with the base, which is the whole amount, and that's equal to the percentage of that part out of 100%, which is your total. I'm going to switch to the whiteboard and we'll break this equation and definition down. So with percentage-based problems, you always have this setup. And it's good to understand why it's set up this way. And we'll talk about how to solve for each of these variables. The first one I'll start with is part. And in the textbook, they call it percentage, but I like to call it part because it just differentiates from where the percent number gets placed. You'll see what I'm talking about as we go along. But I'll refer to it as part. It makes it a lot easier to understand. So part is going to be the portion or the part being compared with the whole amount. Your base, that's the whole amount, and then the rate. That's going to be the percentage part of your equation. So anytime you see a number associated with a percent, that's going to get placed where rate is. And it's always going to be in this order. And we're going to be using cross product rule to find the missing value. And we'll look at the first example. I'm going to erase this now, but I'm going to keep the equation up there. And you know what? I'll put this up here as well. Or I'm just going to abbreviate this as R is equal to percentage. So with the first example, we have 3 over 4 is equal to 75 over 100. And we're going to break this down so that way the configuration of each of these values makes sense in relation to the definition of part, base, and rate. So in verbal terms, if we were to translate this, And this is also in your textbook, page 228. 3 is 75% of 4. Now, if I'm going to break this down, I want to highlight the words is and of, and that indicates what we need to do when we're placing these into our equation, these values. So you'll notice that 3 is 75% of 4. And that's the way I like to look at it. If I break it down with a visual definition or visual equation like that, I can't go wrong. No matter how these applied problems or word problems are set up, as long as I follow this setup here of where I place is and of, and it's always like this, it'll let me know where each number has to go, no matter how tricky it's worded. And so that's the way you actually want to have that definition laid out. We're going to go through different configurations of these problems where we solve for part. Other times we'll be solving for base. Other times we'll be solving for rate. I'm going to switch screens and go back to the textbook. So on page 229, we're going to look at a situation when the part is unknown. When the part is unknown, you'll typically see these configurations where you'll have a percentage and you'll have the whole amount. But the only way to know it's the whole amount is that it'll be indicated by the word of. And so try to get familiar with this setup of the terms in your word problem or applied problems. So what is 30% of 50? Find 30% of 50. 30% of 50 is what number? So it's the same problem, but it's being presented to you in 3 different ways. I'm going to switch to the whiteboard and we'll break that problem down for example 1. So we had 3 types of possible scenarios. First was what is 30% of 50? Next was find 30% of 50. And then we had 30% of 50 is what number? So if I use my equation that I edited and I had part, base, let me put that on the same color. Part base is equal to rate over 100. I'm just going to follow this route of when I'm trying to figure out what goes where. So I know I do have 30%, I have 50. That's consistent in each of these three scenarios. I also know that it's indicating that what is 30%? It's also mentioning of 50. So if I follow this route and I just plug it in the same order that I get, if I have is the rate and of the base, so that indicates to me that I will have a base of 50 and I had is 30%, so that'll go up here. So you plug those in exactly where they're indicating you to plug them in. Now, textbook doesn't break it down in this way, but this is what's always helped me. So this shows me that I'm looking for part. You're always going to have 100 because 100% refers to your entire amount or total amount. So is and of, I'm still following that setup. And this tells me exactly where the 30 and the 50 need to go. So now what I'll do is solve for these, and I'll be using cross product rule to do that. So if I go back to the problem and I have part over 50 is equal to 30 over 100, and this is a proportion problem. So I have a ratio of part over 50 is being compared with 30 over 100. So I'm going to use cross product rule and multiply diagonally and find my missing values. So one thing we want to do with cross product rule, keep the equal sign vertically lined up, and we'll look at our problem as a left side and right side. So on the left side, I could have part times 100. On the right side, I could do 30 times 50. If I multiply that out, I have P100 is equal to 1500. Now, this is where I want to solve for the part. So I'm going to divide by 100 and get rid of it. The reason I'm doing that is if I'm multiplying by 100, I have to perform the opposite function to get rid of it. But whatever I do to the left side, I need to do the same thing to the right. So I'm going to divide by 100 on the right side. So 1500 divide by 100. And if we follow some of the things we've learned about factors of 10, every time I have a factor of 10, they cancel each other out. And so if I break this down in its simplest form, without even using the calculator, I have 15 over 1, and I know that's equal to 15. So my part is equal to 15. I plug this back in to the equation, and I have 15 over 50 is equal to 30 over 100. And now if I multiply these with each other, they should be equal. So in the proportion problem, your left side and right side should be equal to each other. They're just scaled up. And so I have 1500. If I multiply 15 times 100, I have 30 times 50, and that's also 1500. So it's equal, checks off. Another thing you can see, I'm going to rewrite this. I have 15 over 50, and it's equal to 30 over 100. We talked about in section 4.1 about the ratio problems and scaling up and scaling down. If I multiplied this by 2, I would get 30. And if I multiply the 50 by the same factor, it has to be the same factor, because whatever happens to the numerator happens to the denominator. That gets me 100. So they check off with each other. They make sense. These are different ways to check your work. So cross product rule and understanding that concept is going to be very critical, but also this definition, if we break it down and include the is and of setup, that's also very key with being able to break these problems down and knowing where the numbers go. Okay, so I'm going to jump back to the textbook now. And so that was example one. With any of these, you're going to have different configurations verbally, and it might seem like they're trying to trick you, might seem like they're trying to throw you off. If it's easier than the way I presented it, you can also look at it as this way. This is a better presentation of the definition that they had on the previous page. So is over of is equal to percentage over 100. This right here is the definition probably that you want to get familiar with. And if we apply that to each of the following, to any of the following examples, you'll see it's very helpful. So if we were looking at find 8.5% of 160, I know that if I follow this setup right here, I could put, this is going to be part, and that's going to be over, I have of 160, so that's going to be over 160. All of that is going to be equal to 8.5. I could call it 8.5 if I want to, divided by 100. And so if I'm working that out, I'll go to the following page. And you'll notice that's exactly what they had. Part over 160, 8.5 over 100, and you apply cross product rule and multiply it out. Now it's important to have all these steps laid out because you can keep track of what you've been doing and your movements. So if you need to double check any work or cancel anything or factor anything out, it's very easy to see how you progress. And a lot of this can be done without a calculator. You are free to use calculator in this chapter when it comes to the test or the homework. I mean, that's part of the routine now. Make use of it. But, you know, also don't rely on it 100%. You can still do a lot and move a lot faster by hand sometimes. You'll notice when they divided by 100 here, we shifted the decimal 2 spots to the left and it became 13.6. And it's that easy, especially when you're doing factors of 10. Run through some of these practice problems and see how they've solved them out. So you have an application where it's a fractional percent. You have another one where it's just whole numbers or single digits. And you have some that apply to units in the front. So it deals with money or pounds. So depending on what you're solving for, you'll need to keep track of the units. So in this case, if I have pounds, I need to make sure my answer has pounds. Same thing with if I'm solving for money, I need to make sure my answer then has money if I'm solving for the part or the base. So keep that in mind, keep track of the units. When we are solving for problems where the rate is unknown, so that's the percentage portion, you will have a component that the variables that will be provided to you will be your part and your base. So you'll have a portion of the full amount and you'll have the total amount that's being compared to it. So this would be my part. And then when it indicates of, this would be my base. So if I follow that setup, no matter how I look at it, 5 is of 8, or what percent of 8 is 5. It's very straightforward. It can get confusing if you're not familiar with that setup that we saw on one of the previous pages. And so I'll present it in the way that they showed over there. So we had is over of is equal to percent over 100. And that's what you want to follow when you're setting up your fractional setup. And that's what they did right here. So we had 5 over 8 is equal to our rate over 100. Since we don't know the rate, that's what we're solving for. Now that's the variable that you leave as the unknown. And we use cross product rule to solve for it. So we had 5 times 100 on one side of the equation and 8 times r on the other side. I'm going to switch to the whiteboard and we'll work this out. One thing to keep in mind when we're solving for percentage-based problems, it's just presented as the number. You assume the percent is always there. So I'll start with our original equation, part over base is equal to rate over 100. And we have 5 over 8 is equal to r. Since that's our unknown, we're trying to solve for that over 100. We'll have cross product rule going this way, and we'll go this way for the other side of the equation. And once again, it doesn't matter what side each product ends up on. So I could have 8r over here, 5 times 100 over here. And you want to keep that vertical line up when you're solving these out. So obviously we know this stays as 8r. On the right side, this will become 500. That'll be the product of 5 multiplied by 100. Now with 8r, I want to solve for the r. And if 8 is being multiplied by it, I need to perform the opposite function. So I'll divide by 8. So I'll put that as a denominator. Now these can cancel out. Whatever I do to the left side, I need to do to the right. So I'll divide by 8 over here. And when I solve for r, I get 62.5. Well, it's not just 62.5, it's 62.5%. So keep that in mind. When you're solving for a rate, it's going to be a percentage that you're solving for. You don't need to move the decimal or anything. But it's just assumed that it's always a percent when you're solving for the rate. So practice some of these problems out. These are problems where you'll have the rate when it's unknown, and you'll need to look at the is and does setup a little bit more carefully. And you'll have to determine which one is your part, which one is your base. And so pay attention to the arrangement of that applied problem. It can get tricky, they can switch it around, but they're just trying to test your knowledge and understanding of that arrangement. And finally, when the base is unknown. So in this case, you'll have the part and you'll have your rate. And we're solving for the total amount. Now, when we're comparing the ratios, remember when you have a proportion problem, you have two ratios that are equal to each other. And by equal, I mean that your portion of the full amount is equal to the percentage of the total amount. And when I'm talking about the total amount, your base is the total amount of whatever you're measuring. And that is equal to 100%. So 100 always stays there. So that's something you want to keep in mind when you're comparing this ratio on the left with this ratio on the right. And that's what makes a proportion. Whenever you have a ratio, the units on these are the same. And so on the right side, we have a percentage over a percentage. And so that's a little bit more detail than what the book is giving, but it's helpful to know when you're setting this up. Now with this arrangement, they're still using is and of, and you can see how that arrangement gets switched around. And it can get a little confusing. I mean, this is kind of standard where we had 8.7 is 30%. And in this case, they say of, but of is indicated by of what number. So what number, they're indicating solve for base. But it's because you have is and of in that arrangement. I'll use this setup. Let's see. So we'll have is divided by of is equal to percentage over 100. So you always want to keep that in mind. And so it can get confusing on setups like this right here, 30%. And they say of it is 8.7. I mean, they're trying to throw you off and see if you fully understand, and it gets really confusing when they're presenting it this way. But you want to focus on when they're describing a particular measurement. So in this case, 8.7, that's what you're focused on is 8.7. It's the is that you're worried about. And the percentage is obvious. We know that this percent is going to be equal to R for your rate. So let's break this down and we'll work on this problem on the whiteboard. So if I have part over base equals rate over 100, and I'll start working on this, where I know that 30 was for my rate, since it's a percent. So we have percent over percent, and we have our base, that's what we're looking for, and 8.7 was my part. So when I apply cross product rule, I'm multiplying this way, and I'm multiplying this way. Now, one thing I do know is that the percentages cancel each other out from the get-go. So if I was to set up the next line of my equation, I can have B multiplied by 30, 8.7 multiplied by 100. So if I rewrite this now in the next line, I have B30 is equal to 870. And I want to get rid of the factor that's being multiplied by the base. So that's the 30. 30 is being multiplied, so I'm going to divide by it. These cancel out. 870 gets divided by 30 also. I perform the same function to the opposite side of the equation. And I solve for base, and I will get 29. And if you plug it back in and check, I can just check it right at this step right here. So I can say 29 for my base multiplied by 30 is equal to 8.7 multiplied by 100. So this is 870, and 29 times 30 is also 870. So it checks off. But this is my final answer. base is equal to 29. Try some of these practice problems out. Keep track of the units so you can be sure of what you're solving for. So in this case, if my part has a unit of $2, then my answer will be a base with units of dollars. Same thing with part C. If my distance for my part is measured in feet, then my base will be a measurement that is also has a unit of feet. So you want to keep track of the units, and pretty much from here on out, units are going to be very critical when we're solving any of our problems. With the application problems, this is where it can get a little bit trickier. It's a little bit more involved. They're going to throw other measurements or values in there that are not really related to the problem, but it's easy to throw you off. So you're going to have to expand your rule of like is and of. It's going to be a little bit more, going to have to use more judgment when you're trying to figure out where they go in your problem. So with example 5, a moderately active adult weighing 175 pounds needs to consume 2,800 calories per day in order to maintain his or her weight. The nutritionist recommends that no more than 30%. So we already see our rate, 30% of those calories. This is our of those calories should come from fat. So we have of, and when they're mentioning those calories, that's right here. These are related. They're referencing the 2,800 calories. Should come from fat. What is the maximum number of calories per day that should come from fat? So our question is going to be, I'll change the color. What is the maximum number of calories per day that should come from fat? This was the total number of calories, 2,800 per day. So if you look at this setup, the total number of calories, 2,800, is your base. Our rate is 30%. So we know that's going to go where our percentage is located. And our part, that's going to be right here where it's indicating what is the maximum number of calories per day. And so in this case, we'll be solving for the part. So if we break that down, we end up with a value of 840, and you have to make sure you have the units right. So this is 840 calories per day from fat. That's what we're solving for. See what else we have. I might leave the rest up for questions when it comes to the homework problems, and I can work some of these out later in the week. But that's it for section 4.4. So please check that out. Start working on the homework. If you have any questions, I'll open a discussion post where you all can post your questions on there. And if the rest of the class can see it, then I can work it out for everyone. But that's it. Thank you.